And welcome back to another LeetCode easy problem. We're looking at LeetCode 3452, sum of good numbers. If you've seen any of my other videos, you know that this is an interview practice video, not necessarily an explanation video. However, you will also learn how to solve this problem because as part of the interview practice, I also have to explain exactly what I'm doing. So this is me practicing how to communicate during an interview. Okay, let's start with the problem description and understand what we are dealing with. So we're given an array of integers called nums and an integer k, and an element nums I is considered good if it is strictly greater than the elements at indices I minus k and I plus k if those indices exist. If neither of these indices exist, nums I is still considered good. Neither means both don't exist, or if only one doesn't exist. Return the sum of all the good elements in the array. Cool. Constraints. Well, nums contains at least 2 elements and all of the numbers are positive and greater than 0. And the value k is less than, well, it's greater than 0 and less than, this is a weird way to write it, it's less than half the length, less or equal than half the length of the array. Cool. So yeah, let's have a quick look at an example to see if we understand the problem correctly. Specifically, I'm interested in, with the neither thing. So we have an array here. It contains the numbers 1, 3, 2, 1, 5, 3, and k is 2. So I suppose if I'm looking at number 1, the left index, I minus k, that would be at minus 2, doesn't exist. But at plus k, it exists. So the good numbers are nums at 1. Okay, here, this number is not a good number because at I plus k, it's greater than the number at I. So that is ruled out. Now the number 3 does not have a left neighbor at I minus k, because that would be minus 1. But it does have a right one at I plus k here. And 3 is larger. So that's why nums at index 3 is considered a good number. Okay, so cool. So if one neighbor exists, and by neighbor I mean at position I minus k and position I plus k, then we can still evaluate whether the number is good. If both don't exist, then the number is good. All right, so I guess that clarifies these edge cases. And then nums 3 is not a good number because 5 is larger than 2. 1 is also not a good one because 3 is larger than 1 and 4 is larger than 1. But nums 4 value 5, that's a good one because 2 is smaller and the right neighbor doesn't exist, and same applies to 2. Okay, cool. So I think I've understood the principle, and I think we can come up with a solution where we just iterate over the entire array in linear time, and we just try to access the elements at I minus k and I plus k. And if they don't exist, maybe we'll just assume that these values are minus infinity, right? So they always fulfill the inequality that the values there are smaller than whatever our number is at position I. Yeah, I think that's how we can simplify that. So we'll just iterate through it, determine whether it's a good number, and then we just add it to a result variable. So we're going to end up with an O of n time and O of 1 space solution. In the interview, I would ask the interviewer now whether it's good, okay, to implement that, and then they would say, yes, this is a fantastic idea, Mr. Candidate, and I will, continue with the implementation. And I'm just going to write down this time and space complexity that we have, and now I will do exactly as I just said I would. I will iterate over the entire array with an index I, or we need a result variable, correct, to sum up all our good elements. So for I in range, well, length of nums, that's the range. Now we have to get the value left, or should we call this? Yeah, left value maybe. That is in nums at position I minus k, if I minus k is larger or equal than 0. Otherwise, we're just going to print it's minus, well, could be the minimum value. So we know all numbers are larger than 0, so we could just say 0. Or if we wanted to make it clear that this is kind of like a special value, say minus float infinity. Maybe that makes it a little clearer. And same for the right value. And now for the right value, we try to access it as I plus k. And so now we need to check if I plus k is smaller than a length of nums. Otherwise, you also have to assume that the smallest possible value. Cool. Now we have to compare that against our own value, right? So our own value is going to be nums at position. Actually, I could just iterate over the values like so. So now I iterate over the index and I get the value out of nums as well. So now I perform my little check, whether it's a good number or not. And that is the case if left val is smaller than value, and also right value is also smaller. So what we could say that we could just write as value is larger than the maximum of the left and the right value. Makes it a little bit more compact, but it's the same. So in that case, well, it's a good number and we're going to add it to our result. And voila, that's the entire code. Let me just check real quick. Yes, an element at position I is considered good if it is strictly greater than the elements at neighboring indices. So yeah, I'm pretty confident that this will work. So what I will do now is run the test cases. Both of them pass, which is a very good sign. And now let's submit to see if we pass all of LeetCode's tests. And we do. So, solution.